Hi everyone, and welcome back to Snippit Sports Science, proudly sponsored by Elite Form. Check them out at eliteform.com, and also check out their podcast, which is also called Elite Form Podcast, which is available on Spotify and also iTunes. And once again, if you're into this style of podcasting, I actually have another podcast that I run called BFR Radio, where I talk about all things blood flow restriction. Back to Snippet Sports Science now. The last few weeks, we've delved into the world of isometric training, and hopefully with the last 3 podcasts, you've got a really good understanding on the terminology and the type of isometric training that you can perform. With that, some takeaways for me is that it's a good adjunct to traditional strength training, and nothing will really beat the high load, high velocity type training. However, you can have some really good morphological adaptations with isometric training, particularly at the longer muscle lengths and still where you're trying to add some form of load. The next 3 papers which I'm going to go to is looking into specific exercises, and the first one is the isometric squat. And this paper is called The Use of the Isometric Squat as a Measure of Strength and Explosiveness. And this is a paper from the Journal of Strength and Conditioning Research and comes from a group of scientists out of the US. I think more recently when we refer to isometric testing, we think of the isometric mid-thigh pull. However, I thought we'd just delve into the isometric squat first. It's traditionally used with a force plate where you would stick that underneath your body, where you can then push up against an immovable object, whether you're doing that on one leg or a bilateral 2-legged squat. However, having some form of force plate or a force transducer where you can measuring some sort of load, I think is really quite important here. Previous research has established that the isometric squat is strongly related to performance of the 1 repetition maximum barbell back squat. In the past, the use of isometric tests to assess changes in dynamic performance was considered suboptimal, primarily because of the neural and mechanical differences between isometric and dynamic muscular actions. These problems have been addressed recently with multijoint isometric assessments, and in which tasks are close change and at specific joint angles to maximize force. Although it's evident that isoinertial tests, such as a 1RM back squat or a 1RM power clean, and field tests, such as a sprint, agility test, standing long jump, demonstrates greater external validity in their ability to monitor changes in dynamic movements. And there are limitations to isoinertial and field tests that can be overcome by multi-joint isometric testing. For example, shot putters may improve their overhead shot throw performance. However, this does not indicate which specific strength quality, such as maximal strength, rate of force development, or time to peak force, has improved. Therefore, multi-joint isometric tests, such as the isometric squat, can be used to complement and augment isoinertial and field-based testing results. Speaking personally as a strength and conditioning coach, I actually use isometric testing myself, and as the introduction here alluded to, it has some sort of correlation to strength output, and I use this isometric strength test. In this case, it's a single leg isometric strength push in conjunction with vertical jump and other sort of tests to get a feel for where the athlete's at and where they're improving. And one thing that in the introduction is around the time taken to perform this test is a lot quicker than doing a 1RM squat. And in particular, a single leg squat. This paper I refer to is a 2-legged squat. However, I'll use a single leg squat, and when I refer to the athletes that I work with, I'm working with a lot of track and field athletes, in particular sprinters, and therefore my own viewpoint here, I think it has a much greater transfer if I can be looking at single leg strength and then also comparing left v right. Anyway, back to the study here. The purpose of this study was to further explore the use of the isometric squat as a measure of strength and explosiveness for training studies. Specifically, the study elaborates on the relationship between kinetic variables from the isometric squat and isoinertial performance measures, and considers practical applications for its use as a testing measure. It was hypothesized that the isometric squat would be a reliable measure of strength and explosiveness in the sample tested. Correlations between dynamic and isometric measures would be joint angle specific, and isometric measures of maximal strength would be more strongly related to 1RM results than to measures of explosiveness. Moving on to the study now, the subjects they recruited was 17 college-age males with at least 1 year of resistance training experience using the back squat. And they also had a 1RM back squat of greater than 1.3 times of body mass. A point here which I think is really cool was that although the subjects in the study were not athletes, their initial strength levels were comparable with that used in previous research in athletes. For example, the group on average had a body mass of around 84 kilos, standard deviation of plus or minus 8.5, and they had a 1RM squat of 148 kilos. That was pretty much to parallel from my understanding. We'll get to that in a little bit. And they had a partial squat of 224 kilos. So therefore you see here that although they had a requirement of greater than 1.3 times body weight for a 1RM squat to a pretty good level, they were getting close to 1.7 to 1.8 times their body weight. I think that's quite rare to have athletes or subjects of that kind of strength level in a study. So from that there, I think that although they say they have a low training age, they're actually reasonably strong for the subjects they have in this study. With respect to the training that the subjects performed, they trained twice a week for 3 weeks, and during this phase the subjects were familiarized with isometric squats at 90 and 120 degree knee angle. The subjects followed a blocked periodized model with heavy and light days within each microcycle to manage fatigue. In this here, they actually don't refer to the training they did, but they did reference another paper, and I'm now going to flip over to that to tell you what they did. And according to the study design that they followed, subjects trained with heavy and light days to manage fatigue and avoid training to failure. The squat loads differed by 10 to 15% between the heavy and light days, with light days performed on the second day of the microcycle. The load for the squat and partial squat was calculated using percentage of pre-intervention 1RM. Referring to this other study which they took their training program from, the squats load differed by 10 to 15% between the heavy and light days, with the light days performed on the second day of the microcycle. The load for the squat and the partial squat was calculated using percentage of the pre-intervention 1RM. And with respect to the exercises, rather than actually explaining what they did with respect to the isometric squat within their training program, they referred to another paper which I then got up, which is actually from an author called Bazyler, and it's called The Efficacy of Incorporating Partial Squats into Maximal Strength. And what they seem to do here, they didn't actually put the sets and reps in the actual paper, which I found to be interesting. However, what they did do is they did 2 exercises. One was a full range of movement squat, and the second one was a partial range of movement squat from 100 degrees of knee flexion to full lockout. Once again, there was no sets or reps, so I can't really comment too much on what they did in the program to draw it across, which I find it a little disappointing, to be honest. However, I'm going to get back to the paper here and let you know a little bit more with what happened. With respect to the different tests that they performed, in the dynamic strength assessment, they performed a back squat, and the depth was determined by the top of the leg at the hip joint had to be below the knee. And for the partial squat, the bar was set on safety pins at a height corresponding to 100 degrees of knee flexion. And this obviously corresponds to the training study that they're referring to. And in that there, they performed a progressive 1RM test. The isometric strength test was done on a force plate where they're able to lock in the bar at a certain pin height. They looked at 2 different scores, and the first one was an impulse, which was calculated from the force time curve as the integral from 0 to 250 milliseconds. And the second factor was the maximal force recorded from each trial. And this was performed at 2 different knee joint angles. One was 90 degrees, and the second one was at 120 degree knee angle as well. And in the paper here, they refer to a deep joint angle and also a high joint angle as well. Therefore, overall, quite a simple training study here where the subjects trained twice a week for 3 weeks, and they performed 2 exercises. One was a full squat and the second one was a partial range of movement squat. They assessed their strength pre and post, looking at 2 different squat depths. One is a full squat where they had the hip joint below the knee angle, and then one was a partial squat at that 100 degrees of knee flexion. They also looked at isometric strength assessment, looking at impulse and also maximal force at 90 degrees and 120 degrees of knee joint angle. And from here, they just tried to form a relationship between all these different variables to see what would come out. Overall, the 1RM squat and partial squat data was pooled from pre-training and post-training. Correlation tests were used to assess the relationships between the dependent variables of the 4 testing methods. To assess the relative strength of correlations, calculated R values were evaluated using the typical scale that we would see, where something of 0.5 to 0.7 would be strong, 0.7 to 0.9 would be very strong, and so forth. When I refer the results here, it may be a little bit confusing, so potentially to try to keep this a little bit simpler is that remembering in the isometric test, they performed it at 2 knee joint angles. One was 90 degrees, which was more the full range, versus 120 degrees, which would be more akin to, say, the partial range type movement. And once again, in the squat, they had the full range, which was more around parallel, versus the partial range at 100 degrees. So the angles don't quite measure up. However, when I mention 90 degrees with the isometrics, think about a greater full range as opposed to the 120. Because when you actually see the results here, the values obtained from the 90-degree isometric squat seem to better represent performance in the full squat than variables from the 120-degree isometric squat. And this was based on generally higher R values between 90-degree isometric squat and the full 1RM squat. And the R value here was 0.864, and this was between the 90-degree isometric squat and the full 1RM squat versus 7.9. So a little bit of difference there between the two, therefore saying that the deeper joint angle seemed to have a greater relationship between the two variables. Another interesting finding of this study is the somewhat load share variance between the impulse at 90 and 120 degrees and between the rate of force development at the same sort of angles. And this had R values of 0.6 to anywhere to 0.44. And this is because although there is some degree of generality between rapid force production ability, it seems that there is a high amount of joint angle specificity for rapid force production. Therefore, the ability to produce a high amount of force quickly at 90 degrees does not guarantee the same at 120 degrees of knee joint angle. Another way to perhaps illustrate this was through another study by a different group of authors, and they found that peak rate force development, where they had a 10 millisecond sliding window, generated in an isometric leg press task at 120 degree knee angle was strongly related to jump squat height. This is R value of 0.71, and counter movement jump height R of 0.69, whereas peak rate force development measured during the same isometric task at a knee angle of 90 degrees was only weakly related to squat jump height and counter movement jump height, and this was R values of around 0.3. And this just reinforces the point that joint angle specificity to dynamic tasks is supported in other studies as well. In this study here, they actually found strong intra-session reliability, and this was also reported in previous studies for peak force. Therefore, this really establishes that the isometric squat can be replicated for multiple consecutive maximal attempts without negatively affecting testing results. The flip side of this is traditional 1RM testing, and there may be discrepancies in 1RM results because of difficulty in selecting appropriate maximal attempts, differences in warm-up protocols, and an inability to perform numerous maximal attempts without negatively affecting performance. Once again here, the isometric squat does not seem to be affected by this limitation, and an accurate measure of maximal strength is not negatively affected by poor choices of previous attempts within a session. In other words, the advantage of an isometric squat is that you can get in and you can push hard, and that across multiple consecutive maximal attempts, there is still a strong intra-session reliability. Also, I know personally when I used to lift heavy that a 1RM test with a barbell was quite taxing, and I had to have good rest between attempts, and I may not be able to attempt that near weight for another good couple of weeks just due to the amount of fatigue that it may be associated with. The authors went on to say that to reduce the risk of injury, the subjects were instructed to position their back on the bar the same way they did during training before the initiation of the test. The subjects were instructed to hold this position with constant tension on the bar to ensure that the subjects maintain a rigid torso before the maximal push against the bar. Instant visual feedback of the force time curve was provided on a computer screen to accomplish this. To terminate the isometric squat test, the subject stopped pushing against the bar, whereas during a 1RM failed attempt, the spotters had to grab the bar to assist the subject without putting the bar on the rack or lowering it to the safety pins. And I think that's always something that I have a consideration around isometric testing, is the potential for the amount of stress through their back. And I think this is a really nice way of saying that they were able to place the bar with a constant tension, and they were able to actually then see the feedback on the force time curve throughout the whole movement. And at any time that they can't accomplish it, I would assume that they could just pull out of the test and there would be no need for having to worry about a great load that's already in the back, as when you compare to having a bar with lots of weight. So that's a really good advantage of using an isometric test there. As with the first few podcasts that I spoke about around specificity of joint angles, once again here the authors state that the isometric squat can only be used to assess changes at specific joint angles and body positions, which may not directly dictate ability to perform a multi-joint athletic task. As we saw in this study, the deeper squats correlated better with the deeper isometric strength test, and also partial range of movement squat correlated stronger with the higher 120-degree isometric strength test as well. So once again here reinforcing that specificity of joint angle. If you're going to squat deep, your isometric test will probably reflect that, and therefore obviously the partial range of movement should reflect that as well. Therefore, I think from a practical viewpoint, we need to be conscious of the joint angle that we're testing the athletes at, and then possibly does that have specificity to the event they may be doing. As a further example, with the isometric single leg squatting tests that I do with the athletes that I work with, I will use quite an upright position of more around, say, 160 degree knee joint angle, 150 to 160 degree, as I see that a much more specific joint angle when they're in a single leg stance when they're sprinting. And I think that would have potential greater carryover than if I got them to squat at a knee joint angle of 90 degrees. They'd be looking at me going, this has no specificity to my sport. So I think that's really important to say that we're seeing all this data from a test, but then when we get our athletes to do something in the field and as a practitioner, to make sure that they're able to relate to it as well. I think also it's important to understand that these isometric tests perform one part of a much broader picture here. And in this paper here, they've once again referred to the example of a shot putter. And with respect to their traditional strength training, and over the course of consecutive microcycles during a taper, they actually may change their exercises they performed. So they may go from a half squat through to a quarter squat. And therefore, how can you actually keep assessing their changes in strength of whether they've gone up or whether they've gone down, or more importantly, are the athletes still moving forward during the taper leading up to this competition? Therefore, they've suggested, and I can actually see this point here, is that performing isometric squats at, say, 120 degree knee joint angle before and after the taper would provide this kind of data to corroborate the changes in the throwing performance. In other words, because the squat depth has changed, we can't directly correlate the strength changes we've seen in the gym as to whether that relates to performance. But rather, if we use an isometric squat test at a set joint angle, that any sort of changes pre and post may be reflective of changes in lower body strength, and therefore may be related to performance changes in the actual event itself. And then the other advantages here is that the test is really quick to perform. The risk of injury and energy taken to do it is really low. And that also, if you've got the right kind of force plates, you can actually start to assess bilateral strength asymmetries in the lower extremities. And this then could also then have potentials for detecting injury potential as well. So another really positive offshoot there. That concludes the end of that paper review. Just as a whole, once again here, I think it shows that there's another good test you could use there that's not just an isometric mid-thigh pull. It could be an isometric squat, that it can be performed really quickly. And if you're using the same joint angle over multiple points of time during a whole training year, that you could actually be changing the exercises up, but still monitoring the one test and use that as a quick guide to assess where your athlete's at. Our next podcast will move on from the squat to the, I guess, what we seem as a more traditional at the moment, isometric mid-thigh pull, and we'll look at how body position can actually affect your outcome there. So not necessarily a direct training study per se, but how our positions can affect the test, and then perhaps what is our most effective from that point forward. Hope you're enjoying this little series. I definitely am myself. I'm getting a lot out of this. that I'm actually putting into my own craft, or I guess refining the craft of what I'm using with isometrics within my traditional strength training practice. And again, thanks for listening, and thanks to Elite Form, and I'll see you guys in another 2 weeks.